Okay, in this video, I will solve the question number 4 and 5. So using Excel solver to solve this problem. I think every time we use Excel solver, we need to make sure we know how to, based on the case, to set up your Excel to help you to answer the question. Okay, so what I'm showing you is the Excel sheet we use to solving the case 1. What we're gonna do is we're gonna creating a very similar for table, parameter table, decision variable, object function table, and a constraint table. So every time you work on your problem, you need to know based on the case to identify these 4 tables. So nobody will help you to see how to lay out these tables. So make sure as you are looking at these 2 unique case and you are able to learn how to set up your own 4 tables. Okay, so first, let me call it a 2. Let me enlarge this. Okay, so the first table, as I set up, just remember it's called a parameter table, right? So when you're creating parameter table, the first thing you need to do, as I discussed, is to identify your choice variable, right? We already identified my choice variable, older, newer, special from the previous video. So therefore, we just need to lay them out. Newer, older, special. Okay, after we do that, and then we start to lay out my lay out the parameter value related to the constraint, and then parameter value related to my objective function. So the first constraint we learn is called a powder mix constraint, right? So the powder mix has powder mix, and then after that we also learn is called concentration, right? Concentration, concentrated. Concentrate. I need to change my typos here. Concentrate. And then the other one is called, so the facility is only related to one of the facility. So it is total okay, we just leave it there. But we definitely need to recording the powder mix constraint and also the parameter related to the powder mix and the concentrate. And then all of them are measured by ounce. So it's nice to help yourself to understand by ounce per hour, right? How many they can produce per hour. Again, everything I set up here just allow me to just look at the table. I know what's going on, okay? So as we know, for the powder mix, so the newer, as you see here, so the newer are per hour older can produce 295, newer can produce 385, and the special can produce 350, right? So we just need to write down those 3 parameters value, 385 and 350. Okay, so for the concentration, as we learned from the last video, that basically only have older and newer are producing concentrate, sorry, the T concentrate, not concentration. And so therefore, for the special, they don't produce anything. So the parameter we're going to write down is 260, 375, and 0. Okay, 260, 375, and 0. Okay, so this is the related to my constraint, right? And then the next one is related to the cost per hour. So this is related to my objective function. Remember, similar here related to the profit, right? We talk about the cost. So after we read the case, we know that for each one, they have different cost. For the older, it's 190. And for the newer, it is 260. And then for the special, it's 150. So we just need to record in these 3 numbers correspondingly. So the newer is 190. And then here is 260. And then here is 150. Okay, so now I finished set up my first table, parameter table. Okay. Now we move on to the second table. So the second table, as we call it, called a decision variable table. Oops. So we just need to lay out my decision, right? So the decision is about hour to operate. And then it is related to the newer, older, special. Again, we do not need to put any value in here because later on, my Excel will be able to calculate for us to help us to understand what actually the value should be down there. Okay, so this is my second table. And then the third table, as I call objective function table. Okay, objective function table. So under this table, we do need to creating a formula. Okay, we need to know how to calculating the total cost. So the total cost equal to the hour to operate the newer oh, sorry, I actually make a typo. So here should be older and here should be newer. Similarly, older, newer. Okay, so all the number I recorded is follow older, newer, special, but somehow I labeled the headers incorrectly. But anyway, so now we can start calculating, right? So for the older facility, so the total cost equal to the cost per hour times the hour we will operate in the old plus the newest cost per hour times the number of hour we're gonna let your facility to operate, and then plus the special times the hour we need special to operate. So this is just a formula, so they're gonna be give you 0 because for the decision variable here, they're all blank, right? So this is my second table. It's called a objective function table. Okay, so the last table called the constraint table. Okay, so my constraint table, it is literally related to the constraint we already figured out in the previous question, right? Constraints. And then the first, we're going to calculate quantity produced. And then in the middle here is operator sign. And then the last one is quantity limit. Okay, we kind of set up very similar in the previous question, right? So the first constraint is about powder mix. So the second is concentrate. And then the last one is, what do we call that constraint? It's called a older facility capacities. Okay, we have 3 constraints. First, let's see how we calculate total amount of powder we can produce leveraging the 3 facility. So that is equal to, so quantity produced, so equal to the minimum of the hour, the powder we can produce at the old facility per hour times the hour we actually allocate to that, right? So then plus the number of the powder we can produce at newer facility per hour times the hour we allocate to them, and the plus the number of ounce the special facility can produce times the hour we allocate the special. Again, so you will get 0 here because the currently the choice variable are blank. And so for this operation sign, if you look at initially when we identify, so this constraint has to be larger than equal to, larger than equal to 5,500. So therefore we come here, so the operation sign is larger than equal to 5500. Okay, now we can move on to the concentration. So the concentration here, how many we're going to produce, the concentrated T, it is equal to the number for the older facility, how many they can produce per hour times the hour we allocated, and then plus the newer facility, how much they can produce times the hour we allocated, and then plus what they can produce at special locations, special facility times the hour we allocated. And the push, again, 0. So for this constraint, also larger and equal to, so let's see, has to be larger than equal to 4,000, okay? Okay, so the last constraint is related to the older facility operation hours. So as we see, the older operation has to be smaller and equal to 8. So therefore, how many hours we give to the older facility? So it is representing at this cell. So again, we are not typing the value, we're selecting the cell. And then so for this one has to be smaller, equal to 8. Again, we also have non-negativity constraint, but we do not need to list it on this table because when we are using Excel to solving that, we have the option to check a box to including that those constraints. Okay, so this is how I set up my table. So therefore, I finished. All 4 table is ready to go. Now I'm going to the data tab, choose solver. Now, first to choose my objective function cell, so we will click this arrow, and then that's where my objective function located, right? So it's in A10. And then for this problem, it's not maximizing, we try to minimizing the cost, so therefore make sure you choose minimize. And then the second is to tell the computer where's your choice variables. And so we click this little arrow. So we have 3 choices, so therefore we're selecting all 3 cells here. And push this little arrow again. So now let's choose the constraint. So since in this constraint we have 2 different kind of operator sign, so we will add in 2 constraints. So the first is a group, right? We will put a powder mix and concentrate in the first group because both of them are larger than equal to. And then we'll add in the second constraint, so that in that second constraint we'll use smaller and equal to. Okay, so now we are going to the constraint section, we'll click add. So for the cell reference, and then here we was first selecting powder mix and the concentrate. So that is how we are calculating the quantity we'll produce, right? And then that one has to be larger and equal to, right? So it's larger and equal to. And then select this little arrow again, we selected the limit. Okay, and after that, we need to add another one. So we click add. So the last one is older facility. So in this case, this one has to be smaller and equal to, so we do not need to change that. And then we click this arrow again. We're going to choose the quantity limit. And after that, you can click OK. So double check everything's right? So we have my objective function is in the A10. And then my choice variable is in the from BA to BD, right? BA to BD. And then my constraint, so the first is a set from 14 and 15, 14, 15, B14, 15 has to be larger and equal to the value in D14 to D15, perfect. Then we have another one, B16, has to be smaller and equal to D16. So everything, this is right. Again, we're gonna using simple linear optimization because we are not using nonlinear. So choose simple linear. Okay, and also we need to check this box. By default, it's checked. So we have most of the optimization problem. We'll have this requirement is all my choice variables has to be non-negative. So it's applied here too, since we're working on the hours to operate, right? So it's non-negative. And after we do that, and then we can click solve. Okay, it's very quick. So after I solving that, and then as you notice that it used to be blank, right? It was blank, blank, blank. Now it's become 853.3. So therefore, when we try to optimize the profit, so the older facility need to operate 8 hours, while the new facility operating 1 hour 12 minutes, and then the 1.12 hours, and then the specialty operation will operating by 3 hours, 3.34 hours. And then when we optimize the profit is $3,352. Okay, so again, choose all 3 report, answer, sensitivity, and the limits, and then you can click OK. Now let's just focus on the answer in the report 2 in this this week's learning module. Okay, we are able to see, okay, the optimized profit is 3,352. When we optimize the profit, we are using 8 hours of the older facility, 1.12 hours, 5.12 hours of the newer facility, 3.339 hours in the special facility. When we look at a constraint, we found all constraints are bounded. That means older facility use all the hours they have, and also we are able to produce exactly the amount of order requested, right? 5,500 ounces, 4,000 ounces. So we don't have any leftover need to sell. So we produce exactly the amount they are looking for. So that's when we are able to maximize my profit. Okay, so therefore, to answer the question number 4 and 5, right? So 4 is asking, let's see, the so this is a typo. So it should be asked for how many need to produce in each facility. So then you can say the newer, so sorry, the older equal to 8 hours, newer equal to, okay, what is newer equal to? Newer equal to 5 hours, and the special will equal to, let's see, 3.34. Okay, 3.34. Okay, so this is 4, 5. Profit at when you maximize the profit, that is equal to $3,352.11, right? So $3,352.11. Okay, so this is the answer for the problem. Okay, so hopefully this video is helpful. Again, the most important thing is set up your full table correctly. And if you are able to look at the answer key and rewatch the video to help you on your homework, it will be great.